Welcome back, everyone. Today I wanted to talk about a story that I saw on entomology today, why fungus farming ants could be a source of new antimicrobial compounds. And this is a news article about the impact of ants on modern medicine. And it is in reference to this article that was published in November of 2024 in the Annals of the Entomological Society of America, by researchers out of, I believe it's the University of Mexico, Antimicrobial Producing Microorganisms in Fungus Farming Ants, a critical review on insights into a natural biological defense with biotechnological potential. So you might be thinking, well, I've never heard of a fungus farming ant, and you probably have, actually. This is just another name for the leaf cutting ants, as you see here. So these are the ones that always end up in nature documentaries or BBC Earth or whatever, where you see a big long colony train of ants carrying leaves over their heads. The leafcutter ants belong to a tribe called the Atini, and these are a couple different genera of ants: Atta, Acromyrmex, and Amoimyrmex. And these ants all cut leaves, but they don't eat leaves. What they're doing is they're cutting all of these leaves and taking them back to their colony, and they feed the leaves to a fungus that exists within the colony. And this is a fungus that all new queen ants carry with them when they leave to go set up a new colony. And they feed almost exclusively on this fungus, especially the larval stages of the ants. They are fed the pieces of this fungus. So leaf cutting ants are pretty common in the New World, in the Western Hemisphere, and they can be found from the southern United States through South America. And so they harvest these leaves to grow their fungal gardens. Different species of ants within this a tiny tribe use different species of fungi, but all of these fungi belong to a group called the Lepiotaceae. And what is interesting about these fungi is not only are there different species being used by the ants, but all of these species of fungi have deviated drastically from their wild cousins. So this is an actual domestication situation similar to human crops and their wild variants. So a wild apple looks nothing like the apple that you buy at the grocery store, and that is because of 1,000 years of human domestication. Well, these ants have been doing this for 15 million years. So the fungi in their fungal gardens that they maintain in their colonies have really deviated from their wild type cousins. And not only that, the fungi now have a complete dependency on the ants. The fungi can no longer produce spores for sexual reproduction and disperse themselves naturally that way. They rely entirely on the ants for dispersal and reproduction. And not only that, how this relationship works is the ants don't destroy the fungus by eating it. The fungus bears fruit for the ants, a fruit called the Gongolidia, if I'm saying that right. And they're basically little kind of hyphal packets that the ants can collect to eat and feed to their young. In exchange for this fruit, the ants obviously replicate this fungus by spreading it between colonies, but the ants also maintain the colony or maintain this fungal garden within the colony. And they do this by, pruning and cleaning and stuff like that, but also removing pests. And as you can imagine, a fungus that lives in the ground probably is exposed to a lot of germs. So the ants also have to deal with germs and parasites that will otherwise kill this nest fungus. And fungi are very sensitive. It's one of the reasons why mushrooms don't last very long in your lawn or in the park or whatever, wherever you see them. There's a lot of things that eat fungus, and not just like other insects, which is a problem, but ants have a pretty good defense against that. They'll just, chew them up. But also other fungi eat fungus, and bacteria eat fungus, and different protists and things get in there and they rapidly deteriorate like the mushrooms that you see on your lawn. They're there for a couple days and then suddenly they're gone. And they're gone because everything has eaten them. So there's this serious issue of pathogens and parasites within the colony of the ants. And this is where we get into implications for modern medicine. So in modern medicine, there are serious problems with antibiotic resistance growing it for basically everything, but especially bacterial infections and fungal infections. And there is this issue of not being able to develop novel chemicals that will kill these infections in humans effectively, or at least paralyze them. A lot of antibiotics, what they do is they just prevent the spread of the infection within your body, and it gives your immune system a chance to kill it without being overwhelmed. So it really, a lot of these antibiotics merely slow the spread, or they paralyze the growth of the infection, and then your immune system does the rest of the work. But because of antibiotic resistance, those drugs no longer work, and your immune system can become overwhelmed. This is also true not just for bacterial infections, but fungal infections. And fungal infections have an additional problem in that we don't have very many chemistries that affect them anyway. But because fungi are very, very closely related to animals, there is this issue of things that tend to poison fungi also tend to poison you. So this is a problem not associated with bacteria because bacteria are a distant relation to animals, but fungi are a relatively close relation. So you have very limited choices in what medications you can take if you have a fungal infection. I talked about this a little bit, talking about microsporidia infections in insects moving into humans, that those kinds of fungi are very, very difficult to treat. In fact, there's frequently no cure for many of these fungal infections. So these underground fungi in these ant colonies also have problems with fungal infections. In particular, there is a very, very serious fungal infection called Escovopsis, which tends to annihilate these ant colonies. It gets in and it infects this garden fungus, and it completely wipes it out, and so the colony starves. So there is a very good incentive, or very high incentive, for the ants to be able to battle this Escovopsis fungus, as well as other bacteria that get into the colony that would otherwise destroy the colony, like staph or strep or anything like that would get there. So these researchers from the University of Mexico, they didn't necessarily conduct novel research, but what they did was they went through all of the known research on all of the known species of the tiny ants and kind of collated all of the information that we know about them in order to figure out what all of the defense mechanisms of all of these species for all of their different colony fungal gardens were. And what they found a couple cool things. And this is something that we kind of already knew, but this has really put a lot more information out there. So what you see here, let me change colors here. This is a sample in A here of an underground fungus. These images are from the article, and I will link both articles, the research article and the news article, in the description. They're open access, so you all should be able to read them. You see this colony of the garden fungus. So this is the fungus that the ants are actively growing in order to feed on. And this is what is growing there. So we continuously zoom in, the fungal hyphae, and these are those fruits that I was talking about. So this is what the ants are trying to protect. These are those gongolidia that they can they pick off and they feed to their young, and they eat themselves. And this is the fruit that the garden bears in exchange to the ants for taking care of it. So how do the ants protect this? So the ants walk around here. This is obviously a really zoomed in SEM of the ant. The ants walk around tending to the garden all day. You have ants going out bringing stuff in, and this is where they're bringing in the leaves, and this is where a lot of the parasites can get in on these ants bringing in leaves from the outside, and the ants are walking back and forth, and they can bring in filth with them and all that stuff. So you have ants in the colony that are constantly pruning the garden, weeding the garden, cleaning the garden. And they have a very special type of exoskeleton that have these crypts on them, these little invaginations and things like that, that bacteria grow in. And specifically, these bacteria are in a group called the actinobacteria. And there's a bunch of different species in this group. And the ants carry these bacteria around with them at all times, and they rub these bacteria all over the fungus as they're walking around. In fact, there's so many bacteria on the cuticle of these ants that you can actually see it. And what you're looking for are these white spots. These are massive bacterial colonies. So as they're rubbing their faces on the fungus or rubbing their legs on the fungus as they're walking around or trying to pull insects out or doing whatever, pruning the fungus, they're rubbing these bacteria all over the fungus. And what's cool with these bacteria is these actinobacteria, and there's multiple species of them, produce an enormous number of antimicrobial compounds, which kill all of the pathogens on the fungal garden without killing the fungal garden. So Escabopsis is particularly susceptible to these bacteria, this Escabopsis parasite, as well as other parasites. There are Fusarium parasites, there are strep parasites, there are staph bacteria parasites. And there are more than just these actinobacteria growing on the cuticle. They also carry a number of other bacteria, they carry a number of yeasts, and all of these microbes that the ants are carrying around produce a ton of chemicals. In fact, in this research paper, they collated all the different categories of chemicals that have been found from these actinobacteria, just the actinobacteria, and all of the uses for them within the ant colony. Most of these are antifungal in order to kill the Escabopsis, but some of them are antibacterial and have other benefits. And so now we have all of these new chemistries coming out of this research on these ants and their symbiotes, which can now be used to develop new antibiotics for human use, particularly against fungal infections, which is really, really cool because we have such a huge resistance problem, an antibiotic resistance problem in hospitals and things like that, nursing homes and all this other stuff, where you end up with these explosive nosocomial infections. And it's a huge, huge issue when it comes to human mortality. So the ants might be the thing that saves the day. So I wanted to share this with you. I'll link all the articles and I'll talk to you guys later.